Hey, so welcome back, and this is another daily code problem. So today it's called difference between ones and zeros in row and column, and it's a medium level kind of matrix problem. And so let's take a peek at it. So for this one here, essentially you're just given a two-dimensional array called grid, and you want to output a kind of diff matrix. And the way that you calculate this grid is this formula here. It initially looked confusing, but it's actually pretty straightforward. Basically, all that you're going to do is there's 4 different things you want to keep track of, but you can actually split into just keeping track of 2. And I'll explain to that in a second. But basically, for, say, calculating this column here, this particular cell, here, basically all that you're going to do is you add up all the ones in that row. So there's 2 in the row here, so there's 2 ones. And then you add up all the ones in that column. And so in the column here, there's just one 1. And so you add 1 here. But then you subtract those kind of same things but the zeros. So in the row you have 1 0, so you do -1. And then in the column you have 2 zeros, so then you do -2. And so because you're adding 3 here, and then you're subtracting 3, that's basically just going to get you 0. And so that's why you output 0 in this case. And so you just repeat that 5 other times, or not 5, 1, 2, 3, 4, 5, 6, 7. I can't do math right now. 8 other times, and then you're good. And that's all you have to do. So the reason why I said you only have to really keep track of 2 things, not those 4 things, is that once you count the number of ones in this row, so in this row there's 2, to get the number of zeros, you just take the length and subtract the number of ones. So you just do 3 minus 2 is equal to 1, and well, there's one other 0 in this row, right? So because it's only ones and zeros, you really only need to know the number of ones to then calculate the number of zeros. Okay, so you can kind of think of, okay, how do I want to implement this? You know, if I did a brute force way, like, it could be really bad because you have to keep recomputing for each one of these cells and have to iterate through all the columns and all the rows. So to do that, the trade-off that you're going to make is you're going to use a little bit of storage so that you can save the pre-computed, okay, how many ones do I have in each row and how many ones do I have in each column? And once we save this in a hash map, we can just quickly look that up in O of 1 time. But it comes at the trade-off of space complexity, but it's definitely worth it because otherwise your time complexity would be very bad. So yeah, let's go ahead and implement this. So what that's going to look like is first we want to figure out, okay, how many ones do I have in each row? So we have to calculate num1s, number of ones in each row. And then we're going to store it in a hash map so we can look it up in O of 1 time. And so to do that, what we're going to do is we'll define our hash map. So from the collections library, let's import default dictionary. This just makes it easier to just increment it by 1 each time. You can also use a hash map. And we'll just call this row ones, or just rows, let's call it. And this is default dictionary, and we're set as integer, so by default each row will be set to 0 ones initially. And so to get the number of ones in each row, what you're going to do is you just iterate, so for every row in the range of the length of the grid. But why don't we store this in kind of a constant here? So because it's an n by m matrix, or I guess m by n, I'll just say like uppercase R and uppercase C because I find that easier to understand. Oh, there we go. And so what that's going to be is equal to the length of the grid for the number of rows, and then the number of columns is this here. Great, so now we know the number of rows and columns, so we just want to iterate through that number of rows. And so then all that we have to do to get the lookup for this number of ones in each row is we can just set, okay, at this particular rows at R, it's going to be equal to the sum of all the ones in this row R in our grid. And so by indexing into the grid, we return then that entire row that we're at. So every single column in this particular row R. And then we just take the sum of it. So we sum all the ones in it and we just store it in our hash map. So we can quickly look up, okay, at this index, how many rows are there? And we have that mapping now. Okay, so now we know that. Now we want to do our second step, which is, okay, let's pre-compute and calculate the number of ones in each column in this case. Okay, and so to do that, similar thing here is we replicate this. So we just put it here, and we're going to do a similar process here. Undo that. There we go, and put it. Sorry about that. I'm just going to move me over here. And so all that we're going to do is, now that we move that, we're going to say, okay, now we want to iterate through every single column one by one. And so let's go through every column. And so to do that in Python, there's a bit of a trick where you can say, okay, let's iterate. So for every column in, and we say, okay, we're going to zip this column and put star, and then put the grid. And we just want to enumerate this. Great. And we also just want to convert it into a list, because when you zip it, it turns into a tuple. And I'll explain in a second what this is doing. We want to say columns, because we're updating the columns, and we're summing the output here. I, C, and sum of C at I. Okay, so let's just print this out, and I'll show it to you in a sec. Oh, columns is not defined. That's because we accidentally didn't name it. Great, so you can see this mapping, and that's correct. So we're saying, okay, at column 0, there's 1. At column 1, there's only 1 1. And then at column 2, there's 3 1s. And so now I'm going to explain to you what I just did here. So essentially, what this does is you can actually grab like every single column, kind of like how you can iterate through every row, using like a little zip trick. And by doing this, it actually returns like a tuple. It's basically, you convert it into an array of all the columns. So it just allows you to iterate through every single column in the row. So you can kind of iterate column by column rather than iterating row by row. Okay, so then because we're basically getting that array, we just take the sum of it. The reason why we want to enumerate is just to get the current column index, because since this is returning the actual like array, we need to enumerate to get the current index. Okay, so now that we actually have the number of ones in each column, we can then just calculate our diff. So what we're going to return is this array at the end. And once again, it's going to be a two-dimensional array. And so let's initially fill it with zeros, and it's going to have C columns, and we're going to have R rows, so 4 in the range of n. Okay, so that just predefines a two-dimensional matrix filled with zeros, and then we say, okay, let's iterate through every row in this matrix. And then we want to do the exact same thing, but for every column in this matrix. And then we want to say, okay, with that, what we want to do is we want to calculate this diff. We just use a formula that they define for this function, which is, okay, the difference at this row and at this column is just equal to the number of ones in each row, which is rows at R, plus the number of columns in this particular like index that we're in. And then we just subtract by basically the number of zeros. And the way you calculate the number of zeros in this current row is just, okay, it's the number of, let's see here. In this current row, there is C columns, so then you subtract how many ones there are. And then you add the number of rows and you subtract at this column how many zeros there are. Oh, and we just say R. Great, so that looks good. Not sure what's wrong here, but we'll see if there's something in a second. And is not defined. Oh, right. It's R. Great. And that looks good. Let's try submitting it. And that's the solution. So basically, for time and space complexity, it's O of n by m, or O of r by c, where r is the number of columns and or c is the number of columns and r is the number of rows. For space complexity, basically we just have to have it for whatever the maximum of the number of rows and number of columns. So it's O of the maximum r comma c. I'll draw that out so it's a bit more sense. So because whichever one's the bottleneck, since the number of rows and number of columns can differ, it would just be O of the max of how many rows there are and how many columns there are. Okay, because we have two hash maps here. All right, so yeah, I hope that helped, and good luck with the rest of your algorithms. Thanks for watching.